This is the video for 6.6, and we are talking about systems of linear inequalities. A system of linear inequalities is two or more linear inequalities with the same variables. So for example, if I have y is greater than or equal to 2x minus 3 and y is less than x plus 4 graphed together on the same coordinate plane, I have a system of linear inequalities. A solution of a system of linear inequalities is all of the ordered pairs that are solutions to all of the linear inequalities in a system. So that's what we're talking about today. How to determine the solution of a system of linear inequalities. So let's look at the first example. We have y is less than 2x minus 3, and we have 2x plus y is greater than 2. So I'm going to take the first one and I'm going to graph it. My y-intercept is at -3, and my slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. I'm also going to go down 2 over 1, down 2 over 1. My line is going to be dotted because it's not and or equal to. And then I'm going to highlight down towards those negative y values because it's a y is less than. So now, because I have a system, I want to graph both of them on the same coordinate plane. So now I'm going to take this next linear inequality. You can graph it in that form, but I think it may be easier to put it like that. So my y-intercept is at +2. My slope is -2 over 1. So that means I'm going to go up 1 and to, I'm going to go up 2 and to the left 1. And then I'm also going to go down 2 and to the right 1. Again, my line is going to be dotted because it's not and or equal to. And then I want to highlight up towards those positive y values because it's a greater than. So none of that is new. That's what we did in lesson 5. We learned how to graph inequalities. The only thing that's different here is instead of graphing one linear inequality, I'm graphing two. So remember, the solution for example, this blue line right here, this dotted blue line, the solution of this linear inequality lies in the highlighted region here, but not on the line itself because it's dotted. Now look at the black line. Let's just review what this means. Again, the solution of this linear inequality here lies in the shaded region below it, but not on the line itself because, again, this line is dotted. But I'm looking for the solution of the system. In other words, I'm looking for all of the ordered pairs that are solutions to both of these linear inequalities. In other words, I'm looking for their shared shaded region. Where do these two shaded regions overlap? The solution of this system of linear inequalities lies in this green shaded region right here, because this is their point of intersection. This green area right here consists of all of the xy coordinates that will make both of these inequalities true. So the solution to this system of linear inequalities is right here in this green shaded region. It is the part of the graph that they both have in common. So go ahead and hit pause and work out this on your own problem and determine the solution of this system of linear inequalities. What part of the graph do they have in common? Where are the xy coordinates that will make both of these inequalities true? I want to show you step by step how I'm solving this because this can get a little confusing. So first, I graphed the top inequality, y is greater than or equal to negative x plus 5. My y-intercept is at positive 5 and my slope is a negative 1 over 1. The line is going to be solid because it's an or equal to, and then I'm going to highlight up towards those positive y values because it's a greater than. Then I highlighted the next line. The next line is y is less than or equal to 3x minus 4. Again, you can graph it in that form, but putting it in this form may make it a little bit easier for you. My y-intercept is at negative 4. My slope is a positive 3 over 1. Again, my line needs to be solid because it's an or equal to, and so I want to highlight down towards those negative y values because it's a y is less than. So my answer lies in this green shaded region. This is the area that will contain all of the solutions that will make both of these inequalities true. And finally, example number 2, writing a system of inequalities from a graph. Again, this is not new. You did this in lesson 5. The only thing that's different is I have 2 linear inequalities, not just one. So let's just take one at a time. Let's look, for example, at this solid line. Let's call this solid line black here. And use colors. It helps keep you organized. So this is going to be a y is less than or greater than. We have to figure out what that is, mx plus b. And we went over this in lesson 5, how to do this. Okay, well the first thing I have to do is determine my y-intercept here, which is at positive 4. And then my slope, let's see, to go from one point to the next, well I know it's negative because the line's going down. It's going to be a negative slope. So what am I doing? I'm going down 2 and then over 2. So it looks like my slope is negative 2 over 2, or I can just say negative 1. So I can just say negative x or negative 1x. Okay, well now I have to determine the inequality symbol. How am I highlighted? How is this shaded? Well, in relation to this line right here, it's shaded down towards those negative y values. So I know this is going to be a less than. Then I have to ask myself, is the line dotted or solid? And the answer is, it's solid. So here's the first linear inequality. Now I have to determine the inequality of the next line, or I need to determine the inequality for this line right here. We're going to call this blue, or for this part of the graph here. We're calling that blue. Okay, again, let me just take this one piece at a time. What's my y-intercept? My y-intercept is at -2. I've got a positive slope, and what's my slope? Well, to get from one point to the next, what am I doing? I'm going up 2 over 2, so my slope is 2 over 2, or I can say 1 over 1, or just 1. So I can say 1x is my slope. In relation to this dotted blue line here, how is this highlighted? It's highlighted up towards those positive y values. So you know this is going to be a greater than. And finally, we know that it's a greater than and not a greater than or equal to because the line is dotted. The hardest part of this is determining the shaded region because, again, it can get a little bit confusing when you have two different linear inequalities graphed together. But you have to take it one at a time, and you have to look at the shaded region in relation to this line, and then you have to look at the shaded region in relation to this line. So here, in relation to what I called black, you can see that it's shaded down, but in relation to what I called blue, you can see that it's shaded up. Okay, so go ahead and hit pause and write the system of inequalities from this graph. This line is y is less than 2 over 3 x minus 5, and this line is y is greater than, or equal to. Sorry. Once again, this is y is less than or equal to 2 over 3x minus 5, and this is y is greater than or equal to 2 over 3x plus 2. This is shaded up towards those positive y values, and this is shaded down towards those negative y values. So you can see there's no solution here because there's no area where the shaded regions of these two inequalities are going to overlap.